Air conditioning compressors are the pumps that generate the pressure to circulate the refrigerant through the refrigerant loop. Air conditioning compressors come in four primary designs: single-cylinder piston compressors, multiple piston axial plate compressors, variable displacement compressors, rotary vane compressors, and scroll-type compressors. Keep in mind as we look at the various types of compressors that the function of the compressor remains the same across all designs. All compressors draw heated vapor from the evaporator through the suction side of the compressor. Inside the compressor, the pressure and temperature of that vapor is raised to make it easier for the condenser to give off the heat necessary to change the vapor to a liquid. All compressors are lubricated by oil carried in the refrigerant charge. And all compressors can be damaged if liquid is pulled into the compressor instead of vapor. That said, let's look at the different types of compressors, starting with the single piston type. Single piston compressors are of the reciprocating piston design. Reciprocating simply means that the pistons go up and down or back and forth inside the compressor cylinder. The difference between the pistons in an automotive engine and those in an air conditioning compressor is that the pistons drive the crankshaft of an engine, whereas the crankshaft drives the piston in a reciprocating compressor. The crankshaft of the air conditioning compressor is driven, either directly or indirectly, off of the engine crankshaft through a series of pulleys and belts. The compressor uses reed valves in the cylinder head through which to draw in vapor on the suction side and to discharge compressed vapors through the outlet side. On the intake stroke, the reed valve on the suction side of the head is pulled open by the low pressure created as the piston moves lower in the cylinder. As the reed valve opens, vapor is pulled in by the lower pressure and fills the cylinder. As the crankshaft turns, the piston begins its upward travel of the compression stroke. The pressure of compression closes the reed valve on the suction side. As the pressure increases, it forces the reed valve on the outlet port to open. The compressed vapors are forced through the reed valve on the outlet port and into the discharge line that leads to the condenser. The compressed charge that leaves the cylinder is both denser and hotter than the vapors pulled in during the intake stroke. While there are some inline and V-type two-cylinder compressors, they are only a variation on the single piston design and operate the same way. Axial plate compressors are similar to single piston compressors in that they are also reciprocating. Axial plate compressors are all multiple piston designs. Axial compressors with either 6 or 10 pistons are fairly common on today's vehicles. The engine crankshaft drives the axial plate compressor through a series of belts and pulleys. Axial compressors are often referred to as either swash plate or wobble plate compressors because the pistons are driven back and forth in the cylinder by an offset plate attached to the compressor main shaft. A double-acting axial compressor has 3 bores with 2 piston faces, one on each side of the swash plate. The intake stroke of one side is the compression stroke of the other side as the pistons travel in the same bore. One complete revolution of the compressor main shaft drives the piston from one end of its travel to the other through the action of the axial plate. As the piston is driven down in its travel, the suction necessary to draw in the vapors from the evaporator is created. As vapors on one side of the piston and swash plate are drawn in through the piston travel, the vapors in the cylinder on the other side of the swash plate are compressed. The axial compressors use a suction reed valve plate and discharge valve plate in both the front and rear cylinder heads to provide for the intake and discharge functions. Timing of the intake and compression charges is facilitated by the opening and closing of the individual reeds on the suction reed plates and the discharge valve plates. Variable displacement compressors are a variation of the axial or swash plate compressor. Variable displacement compressors match compressor output to air conditioning load demand by changing the stroke of the pistons. The swash plate or wobble plate on a variable displacement compressor is actually a variable angle plate, where the angle of the plate is changed by a bellow-activated control valve that is located in the rear cylinder head. When the demand for air conditioning is high, the wobble plate will be at its maximum angle and the pistons will travel the full length of travel. When air conditioning demand is low, the movement of the wobble plate is restricted and the plate moves closer to perpendicular. This shortens the stroke of the pistons. Variable displacement compressors regulate temperature by varying the capacity of the compressor and not by cycling the compressor clutch on and off. The rotary vane compressor design provides the greatest cooling capacity per pound of compressor weight. Rotary vane compressors use only a discharge valve that acts much like a check valve that prevents high-pressure vapor from re-entering the compressor. The rotary vane compressor works by a compressor shaft that is driven by the engine crankshaft through a series of belts and pulleys. As the compressor shaft turns, a rotor assembly that has vanes that extend to the wall of the compressor cylinder block is rotated. The vane or vanes seal the compression chamber as the offset rotor turns. Vapor is drawn in through the suction ports as the vane or vanes pass. The compression of the refrigerant begins after the vanes cross the suction ports. As the refrigerant vapor is compressed, there's an increase in both pressure and temperature. As the vanes approach the exhaust port, the compressed refrigerant is forced out the discharge port. The discharge valve closes as the vane or vanes pass the discharge port to prevent the high-pressure vapor from returning to the compression cylinder. Scroll-type compressors are sometimes referred to as screw-type compressors. Scroll-type compressors use the interaction of a rotating scroll and a stationary scroll. Refrigerant vapor enters the compressor suction port and an outer opening of one of the rotating scrolls. The open passage allows refrigerant vapor to be drawn into the passage of the scroll and then sealed off. As the scroll continues to rotate, the passage becomes smaller and the refrigerant vapor is compressed. The compressed refrigerant leaves the passage at the discharge port. The scroll-type compressor has several vapor passages, and each scroll is in a continuously variable state between suction and compression. This results in a nearly continuous suction and discharge pressure at all times. With the exception of variable displacement compressors, all compressors use a compressor clutch to cycle the compressor on and off. In some systems, such as a CCOT or cycling clutch orifice tube system, cycling the compressor on and off regulates the temperature and pressure of the refrigerant pushed through the system. The compressor clutch is typically used to disengage the compressor when the evaporator has reached the desired temperature or when the air conditioner is not being used. Compressor clutches are electromagnetic clutches. Almost all of the compressor clutches found on cars since 1980 are stationary field clutches. A stationary field clutch has the field fixed to the compressor body by bolts. The rotor is held on the armature by a bearing and snap ring. The armature is mounted on the compressor shaft. When there is no current to the field, a magnetic force is not applied to the clutch, and the rotor is free to turn on the armature that remains stationary on the crankshaft. When current is supplied to the field, a magnetic force is created between the field and the armature. The armature is pulled into the rotor, and the complete unit turns. This coupling locks the compressor shaft to the clutch, and the compressor crankshaft begins to turn with the clutch assembly. The refrigeration cycle then begins.